Hi there, Darren here, and welcome to this session on daylight. So daylight modeling, we're going to be effectively using Radiance 5.2, which is the simulation and engine on the back end of Better Building, in order to undertake daylight assessments. And what you'll find is that you can go ahead and use a multitude of ways to assess residential and commercial buildings from a daylight point of view. Now, first of all, let's go ahead and look at our documentation in terms of what it says about daylight modeling on the platform. Here we are over in the documentation, and feel free to use the search function there, because it's going to give you a lot of insight into what's happening on the platform from a daylight point of view. First of all, you build a model. You build a set of zones that accumulate to be your overall geometry, and you decide that you're going to run a metric against those zones. So what metrics do we have? So over here, this is just a very, very quick summary. So we've got the daylight factor, DF, spatial daylight autonomy, sDA, annual sunlight exposure, ASE, and the useful daylight illuminance, UDI. So you can grab some more information on those, but in summary, daylight factor is a simple metric expressing indoor illuminance as a percentage of outdoor illuminance, nearly always under overcast sky conditions. So again, check out the more details down there. I guess the advantage of it is that it's easy to calculate and generally well understood. The disadvantage is that it's a massive oversimplification of daylight, and it doesn't account for some real basic stuff like sun positions and seasonal variation, even shading devices. It's really, really crude. It's very common though. So you may find yourself looking at that. The second one there is the spatial daylight autonomy. And this is more of a dynamic metric that shows what percentage of a space achieves a target level of illuminance. It's typically around 300 lux, and you'll find that in Green Star and that type of thing. And it's for a specified portion of occupied hours annually. So clearly it's comprehensive. It uses the sky sun path and varying sky conditions across the course of the year, as would naturally occur. It's a bit computationally complex, but that doesn't really impact you in any way on the platform. In many ways, daylight factor can actually take longer to simulate than spatial daylight autonomy. As for the ASE, the third here, the annual sunlight exposure, this measures direct sunlight exposure, typically showing what percentage of space receives over X lux. So let's say 1000 lux for more than 250 hours for the year. So again, in terms of advantages, disadvantages, it identifies areas prone to glare overheating, these types of things, and accounts for seasonal sun variation. But it does ignore a couple of things such as diffuse light. And again, it can be computationally intensive, but again, this doesn't really impact you on the platform. And the last of the list is UDI, or Useful Daylight Illuminance. And this categorizes lighting conditions into underlit, let's say below 100,000 lux, satisfactory, let's say 100 to 2,000 lux, and overlit, let's say above 2,000 lux. And it shows time percentages for each. It's a balanced assessment of light quality, so it's interesting to use. However, there are disadvantages. Again, there are always disadvantages. It's subject to definitions of what is useful, for example, and that is a little bit open to interpretation. So that's a bit about the metrics, and then you're going to apply grid against those metrics in order to assess the pretty much the space in which you're, or the boundary conditions in which you're modeling a metric. And then you're going to look at surfaces. So let's include the glazing in those surfaces. So you can look at the VLT, the visible light transmittance of the glazing, plus all the internal reflective surfaces. And then you're going to look at some simulation settings. So let's go back to the platform now and start looking at a couple of metrics here. We can set up, let's say, a daylight factor and a spatial daylight autonomy at the same time. And we're going to set up some grid settings. I'm going to set up some surfaces and then have a look at the simulation settings pertaining to Radiance and shoot that all over to Radiance and process some results quickly in order to get some results back on the platform. Now back in the platform, we have our model, of course, and we have loads of zones in this model. So if you haven't seen this model before, jump into building geometry. You should be able to build this out yourself. There are multiple geometry-based courses that are free to access on all plans. So you'll be able to get access and should be able to build out something similar to this. But we're going to use this model as an example model, and we can run some daylight simulations. So when it comes to the objectives, these are the objectives in the model. Just realize that the direct sunlight coverage wasn't specifically mentioned there in the documentation, so a little bit of work for me to do there. But let's go ahead and just look at excuse me, two metrics, the daylight factor and the spatial daylight autonomy. And as they appear, you'll see that inputs appear on the left hand side here for you to nominate. Just so we can round off our definitions, I'm just going to go back here and pop on the direct sunlight coverage so we can see exactly what that means, and it is defined here, and I'll update the documentation to express this. But direct sunlight coverage is a dynamic daylight metric that quantifies the amount of direct sunlight received in a space. So this is, if you're in Australia, this could be a BESS requirement. So you'd undertake a BESS assessment to work out how much direct sunlight there is in a space. I'm going to get rid of that, and let's jump into daylight factor. Now, once you're setting up a daylight factor assessment, you're going to set it up via an objective. And you can go ahead and assume objectives here for BESS, and these will build out over time, but we're going to set up a default objective here. Once you start setting up your objective, you can see quite a lot of inputs, and they are going to become clearer over time. So let's start at the top. Let's say, okay, we want to do a daylight factor assessment. That's our target there. DF, 2%. That relates to this value here. So if we change that to 1%, change to 3%, let's put it down at 1%, which is a low daylight factor, but with the caveat the daylight factor isn't a useful metric really for looking at much. We're going to look at the daylight factor either as a function of the number of passing zones, the area of the passing zones, the total area of all zones, or the total minimum. I'm going to say the number of passing zones. So what I want is, I want at least 90% of the zones in which I'm going to run a daylight factor to be passing, a minimum 1%. And of those areas, I'm going to expect at least 100% of those floor areas to pass. So 90% of the zones and 100% of the floor area of each zone with a 1% daylight factor as the target. Excuse me, I had to clear my throat there. So that's now being set up, and then we can then make a decision about whether we set up our daylight factor as a function of purpose or as a function of space. So let me go and explain this concept here. So over in spaces, in this particular project, we have a default space. and then we have an office space. Okay, so we could select default space or office space. Excuse me, I didn't save that there. I was set that up again, 1%, and 90% there. So we could select our default space and our office space, and they would be then collated together and form a part of the rule set here to assess both of these. Okay, so I'm going to ignore the office space for a second and just look at the default space. You can also set purpose. So let's have a look at that. If I were to set purpose, what I would need to do is ensure that a purpose was aligned to a space. So I can go ahead and set the purpose here and say that it's either a daytime, nighttime, mixed. These are all generic definitions. Kitchen, etc., etc. And then once I have that there, then I can then say, okay, under my assessment, instead of the spaces, we can then say, okay, I want to only look at the daytime spaces, look at the daytime and the nighttime spaces. So it's just a way of distributing information. Now, one of the things about purposes is that they don't need to be set at the space type. So under the space type here, I set the purpose up there a second ago. I'm just going to delete that. So I've got no purpose here and no purpose here. But let's go, if I go to the model itself and say, do you know what? For some reason, this is the only space that's of interest to me. And I can actually go into the space settings at the zone level and then apply the purpose here should I wish to. So if I create a custom purpose at this level, hit save, then I can then source only that room for the analysis. Hopefully that makes some sense. So I'm not going to do that in this case. I'm going to do all the default spaces there, and just to get a larger data set to look at afterwards. And then I'm finally going to customize this in order to just customize the rule setup here. And let's say I want to change the title, and I want to say whatever NCC 2022. You can see that's being updated now. And then you'd have to update the target. That's probably not the best nomination there. Let's say concept, something like that, concept daylight factor 1. There you go. So that's how you set up daylight factor. If you go to spatial daylight autonomy now, actually let's go on a slightly different avenue here. We can just set up a rule set based on non-residential buildings for Green Star, and then we have effectively the rule set that is coined in Green Star for 40% of minimum area to have 160 lux for 80% of the hours between 8 AM and 6 PM. And then I'm going to just look at this on the 21st of each month, and then I'm going to nominate, let's say, Green Star here. Okay. Oop. There we go. That's now nominated there. So we've got a couple of different assessments going on. Daylight factor, Green Star. Let's now go to our grid settings and explain these. Pretty simple. The metric, it needs to have a height in order to locate a plane to grab information from. So we're going to set that here. So it could be anywhere between 0 and 0.75. That's a desk height there. I'm going to leave it at desk height and move on. Grid settings could be larger for a factory or warehouse. I'm going to make it smaller just to get the greatest amount of information out of this model. And you'll probably find that you can get slightly variable results subject to the grid that's distributed and the shape of the zones that it's distributed to. In terms of the grid source, you do have the ability to customize a grid, and that's where you draw the grid. And I'll quickly show you where you draw a grid. So go to your levels, go into your level, ground, and left click daylight grid, add daylight grid. And then what you can do here is you can just fundamentally say, okay, I only want to look at that there. And that's all you would do. That would be your custom grid. So we can then go ahead and look for that custom grid. But again, we're not going to do that. And that's only really useful for a couple of quite abstract requirements. So sorry, I keep forgetting to save that. That's a lesson for everyone. Make sure you kind of hit update, and that's a save point there for that particular assessment. So going back, so that's the grid. We're going to automate the grid, so we're going to create a combined automated and custom grid, although we're not actually using the custom, so I'm just going to use automated grid just for clarity. This grid size is going to be offset from the external boundary by 0.2 meters. And you could do that for the internal and any internal shading that is included in the model. So if you draw shading and that shading interacts with the grid, so you put shading on top of a grid, then you're not going to include that surface in connection with the grid, and then you can offset from that. Okay, so I'm going to leave these at 0.2. In terms of the mitered corners, this really just means that when we see results, are the results mitered or are they rounded on the corner? Again, an abstract requirement. And then for how it looks, you have viridis, plasma, inferno, magma, cividis. We default to plasma, and it's just the classic. Next, surfaces. So this is where you can opt in for custom surfaces or use a generic surface across your model. So I'll talk about the generic surfaces across the model first. For wall, ceiling, roof, and shading. So these are just reflectivity values, and these will be nominated by the proposed materials on your project. Hit up our documentation for more information on that. We also include inputs for specularity, for wall, ceiling, and floor, and for roughness, wall, ceiling, and floor. So all of these can be nominated, and these will make a difference. The values you see here are for generic internal finishes, and generally you shouldn't need to touch these unless you have a specific aesthetic that is going to clearly be different than standard internal construction finishes. If you wanted to be specific to a surface and customize it, you can do so here. And this is where you can use spaces, let's say an office space, the office space core to this building, and we can say, okay, the office spaces have an alternative wall reflectivity or ceiling or floor of X. Okay, let's say the floor is a slightly different color, for example. Then this will be built in to your model. And of course you can duplicate this out many times as well, so you get full control over your design. I'm not going to do that in this case. I'm just going to leave everything generic because this is a concept model. And then we have a bit of an override here if you want to customize your ground reflectivity and do not want to use the model settings, then you can just simply override it there. And that's for the external ground surface. Finally, we have simulation. So these are super important. And I'm just going to open up the custom settings just to give you a feel for what's happening here on the back end if you were to nominate a low or high scenario. All our defaults for low and high are in our documentation, so please have a look. But effectively, when you're modeling radiance, you need to make a call on lots of conditions, such as ambient bounces, which are probably the most well-known, divisions, super samples, and the resolution of the model, and the accuracy in order to generate effectively a profile of whether it's a high resolution or low resolution model or somewhere in between. These are extremely deep and sensitive parameters, and we've sought, I guess, our defaults from the developers of Radiance. So for most cases, you're not going to need to jump into changing these, but you can, which is the important bit. In this particular model, I'm going to run it on low because I want the model to come back in a reasonable amount of time. But if you run it on high, it's going to take significantly longer. And that's all you really need to set up from a model perspective. Now, I'll just jump into a couple of other things that impacts the model. The step size, solar distribution, these can all impact the models, how long it takes for the model to run. And a model like this is going to take a reasonable time to run. Critically, this has lots of local shading, lots of surrounding shading. This might take 20 minutes to simulate. Okay. If you go into calendar, you can adjust your daylight savings should you want to here. And I think that's about it. I mean, obviously you got your climate files. This all makes a difference. I'm just going to run it like this on an hourly, hit save, and then go back to simulations. Double check. This is what I would suggest you do. Go ahead and make sure this all makes sense. And then in this particular example, I'm not going to run this in my browser because it might take a little bit long. So what I'm going to do, I'm going to hit save results there, and I'm going to use our credit system to go ahead and run this on our server. So what this is doing, it's going to literally take 1 credit, which is very little. It's, I don't know, 45, 60 cents or something like that. And it's going to simulate it on our server, and it's going to be much quicker. So there's 5 credits in total for this particular model. You don't have to do this. You can do this in your browser as well. But I'm going to run this as a test model and hit begin. And once you hit begin, then it's going to batch process it. And this should start pretty quickly because it's quite early in the morning here. But you can see over here, your studies are now queued and will start soon. And you can see a little cog, little spinner up here. That's telling you that something's happening. If you go to view studies, then we can go ahead and see this. And what this gives us is a view of all the studies that are happening in the model, both past. So I can go back to an old J1B3 study, and then we can see the study that's in play at the moment. So we'll be able to see when this simulation starts up, and you can see not much is happening here. It's kind of getting ready to run. It's being prioritized on our server. And once that begins to run, we'll then be able to see the simulation results. So let's go ahead and wait for that. Just as that's running there now, I just thought I'd provide a quick reminder is that you can move away from this screen. You don't need to be concerned about this or wait for this result directly. You're going to get an email once it's complete, and you can see that's now started to run. There's a small little ticker there, 36, 37, 38 seconds. So you can see it has begun. So you can move away from this. This is going to run whatever happens. There's no stopping this from simulating at the moment, unless there's something, an error is found in the actual simulation itself, where then it will stop and you will not be charged in terms of the credits. So that does happen, and it happens on larger models. But yeah, the point there was that you will receive an email in your inbox effectively saying the daylight simulation text model, that should say test model of course, is ready to review, and then you can just hit the link and you'll be brought back to this space here. Okay, so I think that took about 2 minutes by the time the simulation had run, and the results are up there on the right. I can see in the bottom left-hand corner of my screen that I've received an email now saying that this has now been simulated, so your results are ready. So either way, if you hung around or if you waited for the email, you can now see these results. The daylight factor and green star. And we can see, as usual, the pink means we haven't quite met the targets, or is a negative position from a results perspective. So it's telling us straight up that something's not quite working out here. So let's go ahead and see what the results tell us. If we go to view details, as usual, we'll have the summary of all the objectives that have been run. So in this case, we have the daylight factor and the green star. And we have a rule set. Let's look at the daylight factor first, and we're going to go directly to the daylight factor space to look at that. The acceptance criteria was that 90% of the assessed zones must meet the following conditions. Daylight factor is greater than 1, and that's for all areas in each zone. So the model ended up with 22,270 sensor points, and this represented a little under 5,000 meters squared. And there was 99 zones in the model where 4% of the zones achieved the conditions. So not a great outcome from a design perspective, but that is what it is in this particular case. And we'll have a look at justifying if that is deemed to be correct in a second. Let's now look at the rules set for the daylight autonomy. So to meet the acceptance criteria, 40% of the total area across the assessed zones, we needed to have a lux level greater than 160 for at least 96% or 80% of the simulated hours between 8 AM and 6 PM and on the 21st of each month. So some numbers there thrown around. Obviously these are going to make a difference as to whether the sun goes down early, etc. So that can obviously impact that. But across the same number of sensor points, slightly greater area. That must be a function of the rule. And more zones. So there you go. That's actually what's happening here. So we've got more zones included in this assessment. Don't exactly recall why, but I must have had an input difference between the two, and it might be to do with the rule set here or the selection of zones. But we can see that it hasn't met the criteria, where only 16.94 met this criteria here. So let's jump into some results. So we can go into your results here like this, and we can start to see visually what's going on in the model. So this is really useful to look at the building, because you can start to see some variability going across the building. And if we select each zone, you'll be able to see the results per zone, and you can always copy these results out as data or as an image. But you can see what's happening, you can see visually whether it seems correct. Okay, so you're getting daylight distribution. The warmer the color, the greater the amount of daylight distribution. So this is nice for a quick check, but you probably want to go into the levels in order to get a clearer view of what's happening in your model. And we can see in this model here, we've got this large yellow space here, and this is telling us that we have high levels of daylight above that 160 target there for 92.5% of the time. So that's kind of what what you'd want to design towards. But in some of these other spaces here, you can see the lack of glazing means that we're getting pretty poor daylight distribution. Down here, we're on the other end of the scale. You can see that very little of the time are we actually meeting the requirements in terms of that objective. So not a great outcome, but as we go through the model, we can start looking at the different levels. Let's go up the building and getting a feel for how we can improve the design. Should you want to go ahead and get a bit more space here, you can hide some of that information over there. You might want to change the styles in your model. So you can change the color of the opaque surfaces, which in this case are those walls there. I'm just going to go ahead and change that to this color here, just so you can see it is with this has just kind of changed its background color. You can change the rendering color here, so this just clamps down to the 0 to 100%. But should you want to change that, you could. So we could bring this down like this, because we know there's a lot of data points very low, and if you click update that, we'll start to get more kind of yellow areas, and those are the areas that have the higher daylight. So if I did that one more time, I could really kind of get a more expressed view of the daylight, or the low levels of daylight distribution in the model. Let me go back, put this back at 100%. And for the point results, let's go ahead and change the view to have a look at that. So the point results are these data points here. We can see 0.00. To look at these, it's often useful to go to a top-down view, selected on the right hand side, and then left click and drag, and we can start to see some numbers. So let's look at this zone here. That's pretty interesting, this zone here. We can see a large amount of daylight as a function of the glazing here, and very low here. I want to then go into my point results. And first of all, I'm just going to change the color of the result, update that, zoom back in, and now we can see that it's white. I'm then going to change the size to 10, update, zoom back in, and we can see now it's getting pretty tiny. But then I'm going to change the spacing and make them far more frequent every 1 meter, update, zoom back in, and now we can see data points across the design. Now this can really help from a visual perspective to communicate exactly what's happening in your model. And what I tend to do with this, I tend to want to use this when I'm reporting because it's far clearer as to what's happening. And should you want to do that, I'm going to show you a little trick now. I would suggest that you turn off information in your model. Indeed, turn off everything in your model. So you can then grab effectively this image here. Okay. So if you get that to the point where it's zoomed in, and then you can then go ahead and copy this image. Now the advantage of this, now I've got this copied, is that I can copy and paste that, or I can paste that over my PDF directly in my preferred PDF software. This provides a better integration of the results than what we can achieve from a reporting perspective. We can add these to your report, that's fine, but the resolution that you'll get is far better, and the clarity that you'll get is also better from a communication point of view. So I would suggest that you consider going down this route if you were to want to nominate the clearest possible set of results. Okay, so that is our spatial daylight autonomy. There's not much additional context to talk about when it comes to the daylight factor, other than we get exactly the same set of rules when it comes to reviewing the model, and you can use the same features to see what's happening in the space and nominate, navigate to each zone and see what's happening, and change any configuration to express the results in any way you can. One other thing I forgot to mention here is that should you want to get an index. You can grab this and overlay this onto your drawings as well, which is really useful. But yeah, nothing else to really report there, other than we have lots of failed daylight factor assessments, given that we were looking for an average that was very high of 1, and we can see that very, very few spaces actually achieve that. And the reason it's saying no pretty much across the board is that, yeah, we've just got a very low level of daylight in the space. Now, finally, when it comes to inputs, of course, your inputs are summarized. Here they are here for your materials, for your grid settings, for your windows, which I didn't touch upon. They all have a VLT of 0.6. Then we have our direct solar, which shows you your climate file, and diffuse solar. So all of this is useful. Please check your inputs prior to checking your results, because that's where everything lies. And once it comes down to your report, yes, it can become a bit verbose in terms of what it represents, but there is a lot of information in this model that you may need to consider. So you may want to go ahead and grab parts of this and bring it into your own reporting style, or you may want to go ahead and download both the daylight report and also the Radiance zip file as well. So feel free to grab those. Radiance zip file is really good to confirm exactly what's happening from a material point of view. And the daylight report, you can add your own theme onto it, add in additional information. In many cases, you're going to need to add in additional information to the summary of the report, and you can either do it here or do it as a separate introduction to the report, and then stitch two documents together in order to provide a reviewer with clarity and illustration of competence that everything has been done correctly. For those in Australia, these inputs are effectively mandatory from a performance-based design brief perspective, so please feel free to check that out. Elsewhere, they're just really, really useful to be very, very clear about what's happening in the model, and maybe why you're doing it in the first place. And that's it. That's all she wrote. So thanks for listening. That's an introduction to daylight, and feel free to go ahead and answer the questions that will follow this video. And you're looking for an 80% pass rate. We don't make them too difficult, but once you do, you get a certificate of competency, and you are off to the races. You have some elemental daylight skills, and you can go ahead and start modeling daylight on each and every project. So thanks a million for listening. See you on the next one. Bye bye.